conic stuff, we're going to use a lot of reciprocals.
Mr. Murphy, that's a 16 under the x squared, right?
I think so. Was it supposed to be 16?
Yeah.
Okay.
Hannah thought maybe it was.
Hannah should get her eyes checked. Joe, you'll get over it. Hi!
Hey, Haley.
Awkward.
Yeah.
So,
Wow.
what happened?
She forgot there was a camera. I went to flex and nobody told me. So I was sitting there and Miss Foster started teaching and I'm like, she's teaching. Good job. I like, no one gets
So here's what happens. Now, you just distribute the 1/16. When you distribute the 1/16, you're going to get y squared over 400 minus x squared over 256 equals 1. And now it's easy. Wow. Excitement.
I thought I was doing that way wrong, but I got it right.
Now, I'll be pleasantly surprised if you figure out the next one, though. Did you figure out the next one?
I don't know.
All right. No solution. There is a solution. You just have to figure it out. Are we okay at this point? I don't have to go through and do A, B's, and C's with all that. Are you guys okay with the idea that graphing these and labeling and getting asymptotes is not that difficult? It just looks weird? Is that okay in assuming that? What's that? Good. I'm glad. So let's look at 41 then.
42.
42. Well, look at that one.
Mr. Murphy, we're round up.
She's dead. Think of the same thing. What do we have to multiply both sides by to get rid of the 25? 1/25. So if I multiply both sides by 1/25, I'm going to get x squared over 25 minus 9y squared over 25 equals 1. Well, that's great. Let's move this out of the way now. But I can't do anything because of the 9 in the numerator. So I have to figure out some way to get rid of that 9 in the numerator, whereas I'm still not going to change the problem. What?
I multiplied this 9 by like the x squared or 25. I multiplied it 25 by 9. Is that correct? No? Okay. Wait, can't you like do it so you like substitute 1 by like 9 over 1, I mean? Or 1 over 9? Yeah.
I'm going to multiply everything by 1/9 over 1/9. I will. Because it, yes. So what's happening here, this is one of the weird cases. This is about as goofy as conics get, aside from shifting and all that kind of stuff. But what happens sometimes within a conic section, you have to eliminate a constant that's in the numerator. In order to eliminate the constant that's in the numerator, you're going to want to multiply by whatever that numerator is its reciprocal over itself. Because what's 1/9 divided by 1/9? It's 1. So what I'm going to do then is I'm going to multiply this to everything. And I'm going to show you how this works longhand first. You're going to get 1/9 over 1/9 times x squared over 25 minus 1/9 times 9y squared over 1/9 times 25 is 1/9 over 1/9 times 1. What I have now is 3 separate monomials. Remember, monomials are a bunch of things put together via multiplication. 2x squared is a monomial. 2x squared y cubed, still a monomial. 1/2 x squared plus 2, no longer a monomial. It's a binomial, 2 parts. So I basically have monomial subtract monomial equals monomial, which means I can simplify each one of those independently. Again, what is 1/9 divided by 1/9. 1. This one goes away, and I'm left with x squared over 25. What's 1/9 times 9? 1. So the numerator becomes y squared. And what's 1/9 times 25? Really? 25 ninths?
Wait, fraction over. Fraction is that?
1/9 times 25.
Oh.
And what is this going to equal? It's going to equal 1.
Oh yeah.
What happens with this one now is that your a squared and b squared, are your b squared value is just a crappy fraction. That's it.
Wait, can you just open the game now? Like where it was like 9 over 25, can you just make it y over 9 over 10? Or can you open
It doesn't always work that clean though.
But you could have done it in an equation.
Did you know to do that?
No, because I didn't think it turned out as a good. I thought there was like an easier way to do it.
This is the only way to make that work because you're distributing out that factor. Because what you're doing here is you're just multiplying by a factor of 1, and it's just a weirdly written factor of 1. That's all. Okay. So this just means then it's an x squared hyperbola, which means which direction is it opening? Left and right. So it's going to go like this. So a squared is 25. B squared is 25 over 9. C squared is whatever all this winds up being. So let's see here. A is plus or minus 5. B is plus or minus 5/3. There you go. And it's just a matter of counting. You're centered at the origin, so your ordered pairs aren't going to be all that terrible. What's going to be weird with this one is finding your slopes, and I'll show you that here in a second. C squared. This is where you need to use your calculator. We all know that to get c squared here, we're going to add a squared and b squared, correct? So in your calculator, all you do is type 25 plus alpha y equals 25 over 9. Dun, dun, dun. 250 over 9. There's c squared. I'm glad you asked. How do you get the square root of 25 over 9? Or 250? So then c is going to equal, well, square root of 250 over the square root of 9. What's the square root of 9? Square root of 250. What's the perfect square that's hiding in 250? I'll give you a hint. It's 25.
That's not a hint, that's telling me.
Shh. So it's 5 root 10. You all right, Lori? I heard you ask something.
No, I was giving you the square root of 250.
Thanks, Lori. Does it matter when you start to figure out, well, I know 250 over 9 is kind of a tough one to kind of approximate, but could you just get a decimal and guess where it's going to be placed in the graph? That's what you're doing, okay? That's what you're doing. Hi, Haley, I'm glad you're not dead.
Hey,
So when you graph this one, oop, vertex go left and right 5. Co-vertex 5/3 is what? Almost 2. Asymptotes. What people are asking about with this problem is how do you determine the slope when your rise is 5 and your run is 5/3? People are like, I don't know what to do. That's scary. Yeah, they do. It's kind of sad. Actually, sorry, the rise was 5/3, the run was 5. Five thirds over 5 is your slope. So you have to understand what that means as far as no longer using what's called a complex fraction. Rise over run. Rise divided by run. So it's 5/3 divided by 5, which means it is 5/3 times 1/5, which means it's 1/3. There's your slope. Or, dun, 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 you have a button on your calculator. What?
No way.
Yes, way.
No way.
I'm telling you, it's crazy. Alpha y equals greatest button known to man. 5/3. Hey, that's going to be a numerator. So what do you think you're going to hit? Alpha y equals.
Yes.
Wait.
It's like a triple decker.
Wow.
What's that? Yeah, it's called a complex fraction. We actually do that. We do complex fractions with polynomial operations in about a couple weeks. We're going to multiply, divide, add, subtract polynomials in complex fraction form. It's a lot of factoring. You're going to love it.
Are we gonna have a problem like this in class?
Like this one? Why wouldn't you? Well, it won't be like this. It'll probably have an H and a K though.
Yeah, even 100.
But you know what to do now, right? What if I just asked you to write the standard form of the equation?
I would cry.
If you just had to write the standard form of the equation, just you didn't have to do the graph or anything. All you had to be able to do was remember that, oh, that's right. I just have to multiply by that funky fraction.
Is there going to be any problems like this on the test?
No, I'm going to give you physics problems and Spanish problems.
Yeah, let's do it.
Last part. I'm going to add a couple problems this evening here, so hold on to that. The last part of stuff that I want to look at is what do you do when you're given information? So this is going to be a hyperbola with center. Again, today we're going to start with writing equations. We probably could have done this yesterday, but I figured with all the graphing and the asymptotes and all that stuff, I figured it'd probably be okay just to kind of just do that bit first. Worry about the writing the equation part here today. Yes, ma'am. Yes.
Is this still 10.5?
Yes, ma'am.
Yeah.
Excuse me. So, just like when we did write the equations of ellipses given certain information, the first thing that I asked that you guys did was write some sort of a sketch of what it's going to look like. This is so important to be able to do because then you'll be able to tell if it's a left-right or an up-down hyperbola just by where the things are placed on the graphs. So let's see here. I have foci up and down, 13, negative 13. And then vertices at 5 and negative 5. So remember, vertices and foci, whether it's an ellipse, whether it's a hyperbola, or even on a parabola, they're always going to be on the same vertical, or they're always going to be on the same horizontal line. Okay? So this means since they're vertical of one another, what direction is the hyperbola going? It's going up and down. It's a happy, sad face. Okay? So I know that's what it looks like. Which equation has the happy, sad face? The y squared first, good. So that means it's going to be a y squared hyperbola. And we just have to figure out what A and B are. In this case, we know what A and C is. That's it. So A is your distance from center to vertex. Both of these have center to vertex A values of 5. Well, they should because it has to be the same. So we know our A value is 5, which means A squared is I don't know what B is yet, but I'm getting there. I know that C is the distance from the center to the focus. Hey, did you figure that out, that there's a C in focus?
Wow.
Here, I'll say it lower. Did you know there was a C in focus? It's about there? Okay. Don't make short jokes.
That is not nice.
Make sure the jokes are I wish I was a short person, honestly.
I got a saw.
I wish I was short. It sucks.
Probably. So,
That was kind of
which means C squared, 169. So let's see, C squared is A squared plus B squared, and we have 169 is 25 plus what?
B squared.
Okay, 144.
12.
Do I even care what B is? No, I just need to know what B squared is. B squared winds up being 144 because those are the two that get substituted in.
So you have to write 144 on your graph?
No, I don't have to graph this.
Okay.
All I'm doing is writing the equation. I graph this so I can visualize which direction it's going, and then I can figure out by counting. That's all I care about my graph. I'm not trying to graph and label everything else. I'm just trying to write the equation. And that's how you write the equation. You just get a rough sketch and just go. It's the easiest way to do it. Okay. Huh? I don't know. Maybe people screw up more often on this board than on the others.
Well, you're the only one that writes on that.
No, Waffhouse comes in here. He writes on the boards. We do. It's just they just get dirty all the time. It's the cleaner. It's the cleaning materials they use. It's just not the big streaks. Do I have to do another one of these?
Was that always your lunch today?
Yeah. What I want you to do tonight are same page, the same stuff. Just add to it here. We'll go 5163 odd. Yeah, just keep it on the same stuff. So same sections is 10.5. It's page 619. You've got a little bit of time. You should be able to at least knock out a few of these. The first three of them are graphing the conic section. There's either going to be a parabola, a circle, ellipse, or hyperbola. You will have to figure out which is which to graph it. Whenever you graph something, make sure you always label everything. What's wrong, Jaden?
Right. Hey, you're just got a compliment.
What's that? Who did? Anna did?
I'd rather.
That's a little too long to be done.
I told my kids that joke. They loved it. They thought it was the funniest thing ever.